Good evening, everybody. What is up? It is Friday, February the 12th, which is the second Friday of the month, which means it is time for the Astronomical Society of Southeast Texas monthly meeting. COVID is still a thing, so we are still meeting on our machines at home, whether it's your iPad or your iPhone or YouTube on the TV, whatever it is. Hopefully, we're coming through loud and clear for y'all. This is going to be a fun meeting. I think it's probably going to be one of our more epic online meetings, and maybe even in-person meetings as far as those go. I see a bunch of y'all jumping in the chat, so welcome to all of you in the chat room. I'm going to go through some intros of who we got on the panel this evening, and we're going to get into some astronomy funness. We got some astronomy news. We got some astrobiology we're going to talk about tonight, which is going to be fascinating. And so without any more talking from me, I'm going to introduce our guest speaker tonight, and then we'll get into some club business after the intros. But Mr. Graham Lau, Dr. Graham Lau, this is your first time with us on this particular broadcast, but it's great to have you, man. It's good to see you again.
It's a pleasure to join you. Thanks for having me.
And you're the cosmobiologist, and that's on most of the social platforms like Twitter, Instagram, all the fun stuff, correct?
Yep, that's correct.
All right, and we're gonna get to your official intro. Just wanted to make sure everybody saw your face and got a chance to meet you before we move on to Mr. Howard Miner. There he is, Mr. Howard Miner. Now, hey. Howard is one of our great members of our club, the Astronomical Society of Southeast Texas. He's been with us for so long, and longer than I've been in the club. And Howard, again, Graham and Howard and I were talking before the show. Howard is one of my main mentors in amateur astronomy, and it's always a pleasure to have Howard here. But Howard, it's also great to see you, man. Thanks for joining us.
Well, I'm glad to be here, and we'll just see how it goes. I think it's going to be a great night.
I think so too. I mean, I hope it is anyways. It's a Friday night. I mean, the weekend's coming, so we at least got that, even if everything crashed down. I know a lot of us are going under a freeze warning. Even down here in Southeast Texas, they're talking about freezes and people sliding off the highways in their cars. So if you're from the Beaumont area, do be careful. We want to make sure that everybody's, here for the next month's meeting. So just prepare for the snow. We're not really good at dealing with ice and snow down here in Southeast Texas, that's for sure. So, that's one thing that we definitely want to keep an eye on. My name is Will. I am the president of the Astronomical Society of Southeast Texas. I've been the president. This is like my 10th year, I think. So anybody else want to do it? Anybody? Going once, going twice? But we're gonna talk some astronomy. We've got some fun stuff. We've got a little club business we're gonna handle before. One thing I did want to mention before we get into anything too deep in the club stuff, I did get this email from one of our members, Carl Dunn. And there is this happening, which I think you guys can see my screen, I hope. Well, I'm hitting all the wrong buttons here. There we go. Virtual Campout. If you are, if you're anywhere, really, because it's an online virtual campout. Normally these things happen at the Johnson Space Center in person, which is pretty cool. But this one is going to be virtual. So this is a Space Center Houston activity. And if you want more information, you can definitely go on to the virtual campout spacecenter.org site here, and you can register. And you can see that right there. And it's just it's a chance for you to get the kids involved. It's a NASA thing, so everything's going to be really top notch and really well done. They give you a bunch of activity lists here, and they want you to register 24 hours beforehand, and it's coming up fast. And I think the date is February 20th is what I think I see here. Yeah. And there's the agenda right there off to the right. You've got all kinds of really cool stuff, guest speakers, all kinds of activities for the kids. So it's definitely something you want to do. And look, after COVID, they start having these again, you want to go get one of these done in reality, because you can pitch a tent underneath like the SpaceX rocket out there at Space Center Houston, which is ridiculous. I've always wanted to do that for no reason, but now that apparently there's a way you can actually do it without getting run off by the authorities. Wow. So that's a little quick announcement from one of our members, Carl Dunn, and then we'll get straight into the club stuff so that we can get to the guest speaker, Dr. Graham Lau. which is going to be fascinating. Again, like I said, so again, we are the Astronomical Society of Southeast Texas. We meet once a month, currently here on YouTube and Facebook, wherever you might be watching us from. And we'll get to some new members here. We got some brand new members. Again, it is 2021. So for all you old members, it's time to renew your dues, which we'll talk about here in a second. But I want to welcome Suzanne James, Joy Schwartz, Vivid Peavy, Stephen Voth, Joe Califf, who we all might know. He might be in the chat room right now, and I think I just saw him. So I definitely know Joe Califf is. Joe is the president of the Houston Astronomical Society, our sister club that has way more members. But it's always good to see them in the house. And Eddie, I think it's Eddie Trevino there at the end there. So welcome to all our new members and all you old members who are trying to pay your dues. There it is. $30 for your whole family. You get all the perks listed below. I won't go through all those. You guys can pause the video if you need to read all of them. It's a lot of good perks. And you're a part of an astronomical family, if you will. So, and we'd love to have you. But dues are $30. I've already got mine in. I know Howard got his in. So the board is basically paid for, which is good. We still have a board for this year. And we'll keep on rolling with that until election time at the end of the year, which is, I think, November coming up. But for those of y'all in the chat room, while we're doing some of this club business, if you do have observing reports, we'd love to hear about them. Put them down in the comments. If you've been observing the Cloud Nebula out there with the ice cluster that's coming at us, tell us. If you've been out with the binoculars looking at the moon, let us know. We'd love to hear about it. I've been observing some stuff, which I'll talk a little bit about here in a second as we go through the club business. Amazon Smile, if you do shop on Amazon, smile.amazon.com. And then if you put our EIN number right down there, you can see that. Or if you'll just type in Astronomical Society of Southeast Texas, like you see in the bottom left there, 0.5% of everything you buy comes out of Jeff Bezos's pocket, and it goes into our bank account, which is awesome. And we've had some really good donations over the years on this program. So thank you, Jeff Bezos, for giving us your money. That 0.5% is actually making a difference in our club's life, if you will. So that's always cool stuff. We'd love for y'all to shop there. If y'all do shop on Amazon, we'd love to have your support. The treasure report is that we're still, the bank account is still good to go. And, Eddie wishes he could be here. Eddie and Kat, they had some business to attend to tonight, so they won't be here. They'll be here next month, more than likely. And we'll get an updated treasurer report from him then, which will be, pretty much the same thing. We got money in the bank, which is good. Texas Star Party is coming up pretty soon, guys. I know May sounds like it's really far away, especially with the winter coming, the winter weather, but it'll be here before we all know it. Trust me. That's the way time works. There's the website, texasstarparty.org. That'll be May 2nd through the 9th. They are still taking registration requests, which you have to request to register. I know that sounds crazy, but it's a crazy demand star party, even in times of COVID. Everything has been streamlined this year. There's no talks. There's no in-person meetings. It's basically just going to be a field for you to put your telescope, and masks and all that social distancing will be required. And there will be a go, no go decision on that coming up pretty soon, like I think in March. So if that's something you're interested in, if you're ready to get out and observe, you've got your vaccine and you're good to go, or whatever the case may be, look into this one, guys. I'm telling y'all, Texas Star Party is amazing. And it's one for the books, like Howard and I and Graham were talking earlier, that star parties really are something that can make the difference in your observing. So that's one to look for. Also, the Rocky Mountain Star Stare, which I've never personally been to, but I do plan to go, if not this year, then 2022. I don't have any information for this year. This is just a screenshot of their website, and this is how it sits right now. So they're still in a state of, are we going to do this? Are we not? Now, this is in June or July, new moon, whenever that is. Not exactly sure what. I think it's probably just like May. It's probably going to be the earlier part of June or July. And I think it's in June. But stay tuned for more information on 2021 is what they say. There's the location in latitude and longitude if you'd like to look exactly where it is to see if it's feasible for you. But it's a great star party. They're going to have guest speakers if that opportunity presents itself. So it's one that I'm definitely doing either this year or next. So if y'all want to go hang out with me out there, let's go do it, because it's a long drive for us here in Texas, but I think it'll be kind of worth it once we get out there and have fun. Hopefully the weather's good. Oh, go ahead, Howard. Have you been
I was just going to say, this is with this cold weather that we have right now, that star party's at 7,600 feet. Don't forget your jacket.
Yeah, nights will be cold. Absolutely.
Even in August.
Yeah. And so it's definitely one that that will require some cold gear, hand warmers, warm socks, all that fun stuff. Yeah. But I'm excited to do that one. Get to hang out with Graham and I's mutual friend Ron. Hopefully he'll be out there with us. So it'll be a good time.
That's not a long drive for me either.
Oh, really? How far is it for you?
I'm about 45 minutes or so north of Ron.
Oh, wow. So this is like a shoe-in for you, man. That's awesome. Well, hopefully we'll see you out there, Graham.
Yeah.
You can come look through my scope.
Before?
I have not.
Oh, okay.
Well, hopefully maybe one of y'all in the chat has been there. Y'all can let us know what your experience was. And as we go through the meeting tonight, I'll throw those comments up. One thing I did want to mention about a preview for next month. I've been going back and forth between here and Boca Chica, Texas, which is where they're doing exactly what you're seeing in front of you. That's 2 rockets. That's not like grain silos or skyscrapers. Those are rockets. The one on the left, the tall one, is in pieces out there right now, which I can actually show y'all. I'm going to do a whole talk on this next month. And this was serial number 9 as it's trying to do its landing burn. Didn't really quite work out for it. And so that was the fiery end of that one. I filmed this from South Padre Island. I'm going to do a talk on this next month again to show y'all, or to tell y'all at least what I think, how you should do it if you want to go down there. Take the kids and go watch a launch because it's definitely worth it. But this was the scene sort of after the explosion. You can see there's only 1 rocket there now. And actually there's 2 rockets, but most of serial number 9 is over here and over there and right over there and more over here. So it's less in one piece. They call it a rapid unplanned disassembly, which I find hilarious. It's such a scientific way to say a crash landing. But I'm going to do a talk on that next month. So come back and see us for that one. Real quick before we turn it over to Graham, who's going to do some astrobiology talking for us. This is the calendar that Howard makes for us every month. It's awesome stuff. You can see we're here on the 12th. We've got a bunch of cool stuff coming up. The moon is furthest from Earth, which is a non-supermoon. It's an unsupermoon, I guess. I don't know. They're always doing supermoons and unsupermoons, whatever it is. It's apogee. There it is. We're here on the 12th. We've only got a couple of weeks left in February, y'all. It's going to be March. I'm telling y'all, this is going to fly by, this 2021. So there it is. And full moon is on the 27th. And like Howard says down there at the bottom, motivate yourself to get out and observe. Naked eye, binoculars, telescope. Enjoy the night sky. That's where we're here as a club. That's why Howard puts these amazing newsletters together for us. And also one thing I don't want to miss is the Columbia disintegration in 2003. And also we had in January, we had the Challenger. So I always want to remember our fallen astronauts who gave the ultimate sacrifice to explore possible aliens that Graham might be talking about. No. So
don't forget the 15th, bow down to Galileo.
Yes. Galileo, without him, we wouldn't have the Galilean moons around Jupiter, right?
Right.
They'd be called something else, like the Messier moons or something, which would be funny. But I agree, yeah. And Valentine's Day, I don't know what that is, but we can just gloss over that. We're good. We're good on Valentine's Day. None of y'all are getting cards from me or candy. So as we get to our main speaker for tonight, this is going to be epic, y'all. I know Dr. Graham. I've been on several live streams with him. Super cool guy. Super down to earth, which is funny because his head is in space, which mine is too. And I love it because we definitely share that in common. Dr. Graham is an astrobiologist and communicator of science. He's the director of communications and marketing for Blue Marble Space. He's a research scientist with the Blue Marble Space Institute of Science, director of logistics for the University Rover Challenge, which sounds amazing. Host of the NASA Astrobiology and SaganNet show Ask an Astrobiologist, which also sounds amazing. I'm going to definitely have to get on there, and I guess that's on Spotify, right, Graham? I guess maybe it is.
Yeah, it is. You can also find all of our episodes on YouTube.
Oh, perfect. Even better. So we'll talk about that here in a second. And he's the research community coordinator for the Hypothesis browser and the Life Detection Forum's knowledge base. And when I practice this, I said life detention, and I'm like, no, I'm reading that wrong. Life Detection Forum's knowledge base. So I'm going to quit sharing my screen and quit talking, Graham, and then you'll be able to share your screen. And thank you again for joining us, man. It's such a pleasure to have you here.
Yeah, thanks for having me. I really appreciate it. Let me see if I can share just this window. All right, to make sure I can see any questions that are coming in, I'm going to try to share it like this. Is that okay, where I still have like the slides over here?
That'll work.
Yeah, since we tried it out earlier, and it turns out if I go full screen, then I can't see anyone's questions. And everyone watching, feel free to ask questions while I'm speaking. If you want to know about any of the things I do, for instance, the University Rover Challenge that Will mentioned is an undergraduate engineering competition that we hold each year, where students from universities from around the world, engineering and science students, will develop and build Mars rovers, and they will bring them out into the desert in Utah at the Mars Society's Mars Desert Research Station, and then we give them a series of competitive events to see who has the best rover and who has the best team for managing their rovers. And so that's a really cool event to be part of. But yeah, let's talk some astrobiology. And yeah, my head is in space a good bit, but I'd say I also spend a lot of time thinking about things here on Earth, which is why I got involved in astrobiology in the first place. For me, as a young person, a lot of what kind of inspired me to think more beyond myself when I was young was thinking about science fiction and things like Star Trek and Star Wars, and even reading things like Carl Sagan's Cosmos, which I've read so many times now. My original copy of the book has just fallen apart. And these things really inspired me to want to know more about what's here on Earth and what's beyond. And a lot of times in my talks, I love to have at least one image of Earth, because it's important for us to remember this is the only place that we know of that has life. And so for any of us who want to study something like astrobiology and try to understand what life is and whether or not we're alone, we do have to consider our world. And for those watching, this is the famous blue marble image taken from the Apollo 17 astronauts in 1972 on their way to the moon. And it hasn't been a long time since this picture was taken. Sometimes we have to remember that Yuri Gagarin went into space 59 years ago now? It's something like that. Someone can correct me, I'm sure. But I mean, and it's still less than 100 years since Edwin Hubble discovered that there are other galaxies out there. Before 1923 or so, we really weren't sure. A lot of people thought that these other galaxies were just nebulae inside of the Milky Way, that we just had one galaxy and that was it. And so there's been a lot that's happened in this past century. And the field of astrobiology itself, a lot of people will talk about, the ancient Greeks, ancient Chinese, ancient people and their views on whether or not we're alone. Maybe you've watched the more recent version of Cosmos and heard of Giordano Bruno and his consideration of maybe there are other worlds out there. And certainly Anaxagoras, the ancient Greek, thought about the potential for other worlds. He even found a meteorite and instantly thought about, did this rock fall from the heavens? Is this a part of a different world from out there? But astrobiology itself as a field is still really young, and we're still just getting around to this question of whether or not we're alone in the cosmos and how to answer that question. The very first time the word astrobiology was used for a scientific book that we know of was from a Belarusian scientist from 1953. So we really haven't had astrobiology around for all that long. There was a paper from 1941 that mentioned astrobiology as being this conception of looking for potential signs of life beyond Earth. But even for NASA didn't actually have the word astrobiology written anywhere or published anywhere inside of NASA documentation until 1996. When some people here might remember, the Allen Hills meteorite announcement came out in 1996, and Bill Clinton came out in the White House and announced the detection of life in a meteorite from Mars. And that was really when NASA decided to change what was called the exobiology program into the astrobiology program. And nowadays, you'll see online astrobiology talked about as the study of the origins, evolution, and distribution of life in the universe. But for me, I like to just call astrobiology our quest to understand the nature of life. And that very much does involve our Earth. Again, we are the only place that we know of right now that has life. And so as much as many of us, we look out at the stars at night, we look through our telescopes and our binoculars, and we want to know if we're alone, part of answering that question has to start with figuring out why we're here and how life has affected our planet. And so there's a lot going on right now in the realm of astrobiology. There are a lot of folks out there who've been using various methods in geology and chemistry and cosmochemistry to try to understand how life might have started here. We have a big question: did life start here? Maybe life started on Venus first and then came to Earth. Maybe Venus was the origin of life inside of our solar system, and then through something called panspermia, it came here instead. And we don't know that yet. But there's a lot of people who are doing a bunch of great work trying to figure out if life started here or elsewhere. How did it happen? What were the key things, the key chemical reactions that occurred to allow that process to happen? And then after that, life on Earth has gone through so much change along with our planet. Our world is very different now than it was in its earliest years. And over the eons, things have changed quite a bit through mass extinctions, large-scale impacts, through changing the atmosphere from volcanism, as well as the actions of life. Our world is very much entangled with the life on it. And so people like myself, I started off wanting to know more about biology. I got into astrobiology by first getting my degrees in biology and chemistry. It wasn't until a bit later that I started studying astrophysics and then earned a PhD in geology. And for me, a big part of it was just all of this crazy diversity we see here on Earth. Life has done some amazing things on our planet. And I think sometimes we take it too much for granted. There's just so much going on our world to allow us to learn more about life and what we might look for out there. And I do see a question from the YouTube from Carl's Cosmos asking if I can talk more about the Perseverance rover and detecting signs of possible past life on Mars. And I'll talk about that in just a moment. But first, let's just start off looking at our solar system. And let's look at Venus. So I mentioned that earlier, maybe life started on Venus and then came here. And the reason I say that is because much unlike Mars, which is further from the sun, it's a much smaller world, Venus is very, very nearly our sister planet. Sure, it doesn't have a large moon of its own, and its density is very different, but it's still roughly the same size and a very similar composition to the Earth. And a lot of recent research in astrobiology and planetary science and atmospheric chemistry is telling us that maybe early on, Venus could have had oceans and maybe was more clement for life as we know it. But as many of you probably know, Venus now is not very favorable, at least at the surface, where the temperatures are soaring. And the pressure is 92 times what we have here at the surface. And these two images, by the way, the one on the left is a visible light image, and the one on the right is a Magellan radar image that's been colorized based on data from the Venera landers that landed on Venus. And I wanted to talk first about Venus because maybe you've heard through the past few months about this idea that there was a potential detection of phosphine in the atmosphere of Venus. Phosphine is a small molecule made of phosphorus with 3 atoms of hydrogen bound to it. And phosphine, to our knowledge, there's no geochemical explanation that we have currently for why phosphine would form in the atmosphere of Venus. That said, we have found phosphine in other atmospheres. It's been found in Jupiter's atmosphere and Saturn's atmosphere, and it's been predicted to potentially be a sign of life for exoplanets. So for looking at other worlds far away, maybe we could actually detect life by looking at something like phosphine. And so finding it potentially in Venus's atmosphere is really important for us. And so that original paper that came out last fall, it used data from two different telescopes, the Atacama Large Submillimeter Array, and then the James Clerk Maxwell Telescope. So both of these are looking in the millimeter, submillimeter region of radio waves and looking at the radio waves coming to us from Venus. And on the right-hand side of this picture, you can see their data from that paper, where you see that little dip in those data. And that dip was inferred by those authors to be a sign of phosphine, to be right in the region where phosphine would be causing the absorption of this radio frequency and causing that dip in the data. But since that paper was published, a bunch of other papers have come out now questioning whether or not that was a real detection. Because we have to always remember, as Carl Sagan once said, extraordinary claims require extraordinary evidence. And that one little dip by itself is not necessarily extraordinary evidence. And there was actually two very recent papers came out on a preprint server called Archive that both say that it seems like going back through and processing the data that they don't have any good indicator of phosphine in those data. And instead, what could have been happening is actual, if there is an absorption, it's happening from sulfur dioxide in the atmosphere of Venus. But myself, I still wouldn't say that it's impossible. And one good reason for that takes us to Mars. So many years ago, when I was just starting graduate school, there was a big argument going on for a lot of us in planetary science as to whether or not there was actually methane being detected on Mars. And I remember there's a scientist from NASA's Goddard Space Flight Research Center named Mike Mumma, who used some ground-based telescopes here on Earth and detected what looked like methane in the atmosphere of Mars in little whiffs of methane. And there was a large backlash from the planetary science community of people who were like, we have no geochemical knowledge for why methane would be there. This is likely methane in the Earth's atmosphere, and you're just seeing it in your data. And a lot of people didn't believe those data. And so there's a very large debate in the literature. And it took several years until we actually had Curiosity at Mars and things like the Trace Gas Orbiter to actually look for this methane. And now we've seen methane on Mars a bunch of times. And so that's the reason why I'm a little hesitant yet to throw out the idea of phosphine on Venus. I think instead we need to get more data and figure out if it's there. There are some upcoming missions that could go to Venus. Bepi Colombo right now is on its way to Mercury. It already had a flyby of Venus this past fall, but later this year it's going to fly by Venus again and could actually take a measurement that could show us if there's phosphine there, which is really cool. But there are some missions that we could launch in the near future as well, some other ideas out there that could let us see if there's anything going on in the atmosphere of Venus, which I think is worthy to do. But since we are at Mars, let's talk about Mars and the awesomeness that is happening right now. In case you were not paying attention at all over this past week, we've already had two very successful missions arrive at Mars in the past week. United Arab Emirates HOPE mission, or Al-Mahal, arrived at Mars and went into a successful orbital insertion. That will just be an orbiter, basically like a big weather station orbiter. It's going to learn a lot more about the Martian atmosphere and sandstorms. It does have a very good camera for getting a lot of great imagery of the planet, but will mostly focus on the atmosphere. And then Tianwen-1, which went down on February 10th here into its orbital insertion, is from the Chinese National Space Agency. They also had a successful orbital insertion. If you didn't see today, there was a bunch of videos. I should have stolen one for this, but there's a bunch of great videos out there on YouTube of showing Mars as it came into view from the camera on the outside of Tianwen-1 as it was going into its orbit insertion. Tianwen-1 is a triple part mission. So it has an orbiter, it also has a lander, and it also has a rover. And so the rover lander should be landing in May. And then after that, it will also have a rover going out onto the surface of Mars, which is awesome. But then maybe for many of us who've been waiting for this, here on the 18th, on Thursday of next week, Mars Perseverance, or Percy, as a lot of us lovingly say, is landing on the surface of Mars. And it's going to be really, really cool. Will and I were talking, and Howard, before this meeting, and I had mentioned that one thing that really bothered me before Curiosity landed was the idea of the sky crane. I was a naysayer. I was really worried that the sky crane wasn't going to work. And if you don't know what this is, with Perseverance and with Curiosity before it, as the mission comes down into the atmosphere of Mars, it has this rocket pack that kind of launches its rockets and then lowers the rover down off of it. And then it lets the rover lay down onto the ground and then just flies off and crashes somewhere, hopefully far away from the rover. And the whole process requires a large number of lines of code. It's a huge feat of engineering. And so I was so glad to be wrong about that with Curiosity. And now I'm excited for next week for what's going to happen. And for this time, and this time they're doing it even different. This time now, as it's coming down, it can actually study the terrain to make sure it's landing in a very safe and good spot before it lets go of the rover, which is even cooler. So a lot of great stuff there. I have this URL at the bottom here of my image. So if you go to mars.nasa.gov/Mars2020/timeline/landing, there's a whole toolkit of resources for the landing there. There's images, video, a whole bunch of cool stuff to watch, as well as places you can tune in on Thursday to actually watch the landing with other people. A whole bunch of live streams will be going on, so I highly recommend checking that out on Thursday. It's going to be a big day for Mars science. As for that question of why we're going to Mars, well, here's where we're going with Perseverance. We're going to land in Jezero Crater. This yellow ellipse is the landing ellipse, so it's the safe region where the engineers designated it to be safe enough to land the rover inside of that region. And there's a lot of really cool rocks, a lot of really cool things here for us geologists to nerd out about. One thing you'll probably notice right away in this picture is this image that looks like a river going out into a delta right here where water came down into the crater. And actually on the other side of the crater, there's also an outflow region where water flowed out of the crater. And so we have really good evidence that this crater has had, if not one, maybe several different periods of being a lake inside of it. And there's a lot of great rocks around to look for. And part of Perseverance's mission is to look for signs of life. So this will be the very first mission on Mars since we had the Viking landers that specifically will be looking for signs of life. And that's really cool. This is a robot astrobiologist, as some folks at NASA have been saying. It's pretty groovy for people like me because this is us now trying to really apply the science to use different instruments on board this rover to see if there's any signs of ancient or maybe even extant life on Mars. And so one place that I've done work myself in trying to figure this out is by looking at environments here on Earth that we can use as analogs, as systems to evaluate how they relate to places like Mars and how life on Earth thrives in environments that are certainly not Martian, not as cold, not as low pressure, but at least closer to the Martian environment for us to try to understand. Places like the Atacama Desert in South America, which is the driest desert on the planet. Places like the Rio Tinto River Basin in Spain. This is a region where acid mine drainage and acid rock drainage have caused the leaching of acidic fluids and iron-rich minerals in this river that causes it to look like a blood red color. And I myself have been lucky to go to a place in the Arctic called Borpfjord Pass to do research on a Mars-like environment in a valley on this Arctic island, where we have these large geological structures called gossans, which we think could actually exist on Mars. And so trying to understand the geology and the biology of these kinds of features tells us what to look for with things like Perseverance. And I use this image to jump then to another reason for me to have traveled to this place in the Arctic. One, this is one of my favorite pictures of all time of my entire life. These little orange circles down here at the bottom of this picture are the tents that we were sleeping in while we were up there in the Arctic for 2 weeks. And then over here to your right, you see a large glacier in this valley. And then coming down from the glacier is this little outflow. But you might notice the coloration of that. Hopefully your screen's good enough to see. It's a yellow color. And that's because at the base of this glacier, we have sulfur-rich materials coming up from the deep subsurface, coming up through the glacier and erupting. And when they come out, they make these large deposits of sulfur, this yellow mineral at the surface here. And so we've been studying this to understand the dynamics of the biology, the geology, the hydrology in a system where fluids are coming through a glacier and depositing all of this material for us to study. A similar place that maybe you've heard of before is called Blood Falls in Antarctica, on the Taylor Glacier. This is another region where fluids below a glacier are coming up at the surface and erupting out and bringing with them materials, elements that are then interacting with the atmosphere and with the biology and changing to this blood red color, just like those Rio Tinto minerals. And the reason places like this are really cool to study on Earth is for going to places like Europa. So we heard earlier the Galilean moons, and this is one of my favorites of not just the Galileans, of all the moons in our solar system. Europa is a fairly large moon, about the same size as our moon, that has what we think is a crust of ice that might be some 10 kilometers or maybe 6.2 miles in thickness. And then down below that might be one of the largest water oceans in our solar system, the most voluminous water oceans in our solar system. We think it could be maybe 100 to 120 kilometers in depth, or maybe like 60 to 75 miles or so in depth. That's very, very deep compared to what we have here on Earth for our oceans. But say maybe Europa's ocean has some similarities, maybe down at the crustal interface where the water meets the rock, maybe there's some heating of the fluids, and maybe on Europa we also have things like hydrothermal vents here on Earth, which are oases for life as we know it. Places where we find albino crabs and cool little shrimps and these long Riftia pachyptila, these tube worms that use bacteria inside of them to help them thrive in these fluids. There's all kinds of cool creatures that thrive in these oases. For me personally, I think in our world's deep oceans, two of the coolest environments that exist are hydrothermal vent systems and whale fall. So whale fall or cetacean fall is when the bodies of dead whales sink to the ocean floor and they create oases or habitats for life. And the same thing happens around hydrothermal vent systems where the heated fluid is bringing out the temperature, the chemistry, allowing for life to thrive. And so some of you might have heard of Europa Clipper, which just the other day we had a pretty exciting announcement come out. So Europa Clipper was tied to the Space Launch System, or SLS, and its success, but now it's been announced that Europa Clipper no longer necessarily has to launch on SLS. And that Clipper right now is looking at October of 2024 for a launch window. And it could launch on SLS or any other heavy lift rocket. And so maybe SpaceX will be launching Europa Clipper or some other company. We'll see what happens. I think SpaceX is the best in the running right now, but there's a lot of possibilities there. But that's really exciting for those of us who want to see this mission launch as soon as we can get it there. Europa Clipper will do orbits around Europa and Jupiter itself. I see from Carl's Cosmos, will Europa Clipper mission be able to dig down deep enough to get to the water? Unfortunately, no. So Clipper will just be orbiting around Jupiter and Europa together. It'll get a lot of flybys of Europa. It'll give us unprecedented mapping, high resolution imagery of almost all of the surface of Europa. And if we get all the flybys we think we could, maybe all of the surface of Europa. And it's also going to look for things like signs of life at the surface and at the very, very near surface of Europa. It's not going to land or drill or anything like that. But it will give us a lot more knowledge about the actual depth of that ocean down below the ice. It'll let us know what the chemistry is like at the surface and whether or not, much like at my field site in the Arctic or down in the Antarctica at Taylor Falls and Blood Falls, maybe there's fluid moving up through the ice, through these large cracks that we see in the surface of Europa. And we won't know until we get there. And so Clipper can do that. Also, there's been potential, there's some data from Hubble Space Telescope data suggesting there might be plumes of water coming out of Europa. And so maybe you've heard before that another moon in our solar system, Enceladus, a very small moon around Saturn, has plumes of water that we've seen erupting out of it. And those plumes, we've actually gotten lucky enough to fly through them with the Cassini spacecraft to measure a bit of their chemistry, but we never expected them to be there. So when we got to Saturn with Cassini, we did not know there were plumes of water coming out of Enceladus already. And so we didn't really have the best instrumentation on board Cassini for measuring the chemistry or even looking for signs of life in these plumes. We have done a lot of really good work there. There's evidence to suggest there is hydrothermal activity on the seafloor of Enceladus. that it is an entire global subsurface ocean on Enceladus. And honestly, I would argue we should get back there as well and do some research. But with Europa Clipper, we are going to now have an instrument on board that is prepared if there are plumes of water coming out of Europa to actually fly through those and actually look for some more of the chemistry and maybe even potential signs of life there. And that instrument's actually being built down the street here in Colorado, which I'm very proud of. Another awesome place in our solar system we've been thinking of, maybe not for signs of life at the surface, but for understanding planetary science and understanding potential history of life, is Titan. So this is a mixed image of UV and IR from the Cassini spacecraft looking at Titan. Titan has an extremely thick atmosphere. Its surface pressure is about 1.5 times what we have, but its atmosphere is so extensive. If you were to put the International Space Station in this image, it would still easily be inside this very thick blue region of the thick atmosphere of Titan. Titan is a world that has a very unique hydrocarbon chemistry going on at the surface. It has lakes of ethane and methane. And here on Earth, we have a hydrological cycle where we have water and rivers and lakes that evaporates and goes up and makes clouds and then rains and snows back down. And on Titan, that whole thing is happening with methane and ethane. It's a methanological cycle where methane is evaporating into the Titanian atmosphere. And even though it's so distant from our sun compared to where we are, sunlight is striking molecules of methane and ethane in that atmosphere and making them reactive. And they're reacting with other molecules. And they're making this hydrocarbon goop, large organic molecules that then rain down. And so the surface of Titan is getting covered in organic goop, some of which we call tholins. But we have a mission that's been proposed and is going to launch called Dragonfly. And it'll be one of the very first drone missions in our solar system. You might know that we have Ingenuity going to Mars and landing with Perseverance next week as a test flight for Mars. But the idea with Dragonfly is to have this 8-propellered spacecraft that will land on the surface of Titan and then be able to pop up and do like little hops and jump around to different places and measure, Sarah Silva, goop, exactly, to measure some of that lovely, beautiful goop. Some of these places where there are sands made out of methane and ethane ices. There's water ice as well all over the surface, but lots of hydrocarbon gunk all around. It is very, very cold, but there still is some potential that maybe we have some signs of life or at least some kind of reactions that could be primitive forms of life or the beginning of life near the surface of Titan. And so I'm super stoked for Dragonfly. It's going to be a really cool mission about the size of a very small car, much like Percy and Curiosity. And so keep your eyes out for that as it comes up. There's going to be some really cool stuff going on in our outer solar system. But there's also astrobiology going on now beyond our own solar system. I know we probably have a bunch of folks watching who are old enough to remember a time when we didn't know of any other worlds beyond our own solar system. It's only since 1995 that we found the very first planet around another main sequence star. And now, the last I checked, it was over 4,300 exoplanets have been confirmed. And that's probably even more than that now, for all I know. And that number is just going to keep growing and growing. We keep finding more worlds around stars, and we're growing the kinds of worlds we can find as well. Those early worlds that we found were mostly hot Jupiters, large gas giants, very close to their stars, had very small periods, and they were much easier to find. We've been watching and looking with better instruments now for long enough to actually have better detections now. And so we're finding more and more. And so a lot of us in the astrobiology community are starting to think that number is not only going to grow, but the number that could potentially be inhabited worlds out there might soon start to grow as well, especially as we get things like the James Webb Space Telescope, which, having a group of amateur astronomers here, I imagine you all know this thing is wildly overdue and over budget. And a lot of us have been waiting for it now almost as a legend. It's been a myth for us for so long. I wasn't even in grad school when this thing was supposed to have been launching the first time. But if things work out and we get James Webb out there, part of what James Webb could do is give us better data on the atmospheres of exoplanets and the chemistry of those atmospheres. But not just James Webb is exciting. There's a whole slew of other potential next observatories that could come up to replace things like Hubble and Kepler and Spitzer and some of these other great telescopes. There are things like Lynx and HabX, the Origins Space Telescope. There's also a group primarily in Europe, but also with researchers around the globe working on the LIFE mission. And so there's a whole bunch of people who are involved now in some of these next generation telescopes that really, they're going to teach us a lot more about cosmology, about astronomy and astrophysics, about the nature of galaxies, the nature of our universe, but they're also going to help us understand worlds, solar systems. They're going to help us understand whether or not we're alone. And that's really incredible to me. And so I think it's a good time then to shift to this quote from Arthur C. Clarke that I like to jump to a lot, that sometimes I think we're alone in the universe, and sometimes I think we're not. And in either case, the idea is quite staggering. And for me, this is something I like to think about fairly often when it comes to whether or not we're alone. As scientists and as people who think logically, we have to admit that we could be alone. With all of these worlds that we're finding, which tell us that there should be hundreds of billions, if not trillions of worlds in our galaxy, we have to admit that we could be alone. But when you start looking at those numbers of worlds that are out there and all the potential places, all the different kinds of chemistries that could happen, it just seems unlikely. It feels, from a very human aspect, it feels unlikely that we're alone. It feels like there should be something else. And so for me, this journey of astrobiology has been part of being involved in this larger part of being human, of finding out the answers to these big questions of whether or not we're alone. And fairly recently, some scientists have even started going as far as to actually say that we're going to find out very soon. Ellen Stofan, who is now the director of the National Air and Space Museum, when she was the NASA chief scientist a few years ago, she made a wager that we would find definitive evidence in the next 20 or 30 years of life beyond Earth. And Jim Green, the current NASA chief scientist, just recently talking about Percy and going to Mars, especially about some of the instruments we have on board Percy, and looking for potential signs of life there and doing sample return, bringing those samples back. He said that it's going to be revolutionary. It'll start this whole new line of thinking. But one thing he said that I kind of bothered me was that we're not prepared for the results. We're not. And I don't know. I think we are prepared. I think we're ready to start dissecting the data to figure out whether or not we could find signs of life. And I think Percy's a great place to start doing it with Mars. But I think, some of these missions I mentioned, Europa Clipper, Dragonfly, some of these things that we have going on are other great ways for us to understand. And these next generation telescopes, they're also going to help us understand whether or not we're alone. And it's a huge time for it right now. Like I said, it's been less than 100 years since we knew there were more galaxies than our own. A lot's happened in the last 100 years. And so you can only imagine what might happen in the next 100 years. And so another realm of astrobiology is really considering what is the future of our species? What is the future of our biosphere? Because if we want to look for life out there, we also have to consider that life out there might be more advanced than we are. And so maybe life out there is what we might call post-biological. Maybe there's a large fraction of living beings in the universe who are no longer biological and instead have transitioned into being machine beings. And we've seen this a lot in our science fiction over the years, but it's something that we really should consider. And that brings me to the Drake equation. This idea of having a thought experiment, a heuristic, something that you'll never get a straight number from the Drake equation. You should get like a range of potential numbers. And really the whole point of this equation is to plug in what we think we know about the current state of the cosmos around us in our galaxy. And it gives us a chance to kind of figure out what we need to know to figure out if we're alone. And I won't go through all these different numbers. I'm sure you can look this up if you're really interested in knowing what this equation means. But basically, it's starting off with the rate of star formation, how many stars we have at any given point of time in our galaxy. And then it's cutting down through those stars. So what fraction of stars have planets? What fraction of those worlds could be Earth-like? Of those Earth-like ones, which could actually have life? Of those that have life, which could have intelligence? Of those with intelligence, who might be communicating with radio waves for us to listen to. But the big thing here in this equation is this last thing right here, this L. The L, Drake added, is the lifetime of a civilization. And again, I mentioned we've only had 100 years of knowing that other galaxies exist. It's been half a century, a little over half a century since the first human went into space. We only had NASA use astrobiology as a term back in 1996. Like, it hasn't been that much time yet. And so when we start considering whether or not we could be communicating with other life out there, one thing we have to consider is whether or not a lot of beings tend to destroy themselves. How long does a civilization last? And should that be something that's really instrumental in our own thoughts about ourselves and how we're treating our planet, our biosphere, and each other? And so for me, astrobiology, it kind of takes me into this place of thinking not just about the stars, not just about our world, but about us and what comes next and who we are. And one of my favorite speeches, I'm sure you've all heard it, is the Pale Blue Dot speech by Carl Sagan. And there's one part of this speech where he says that it's been said that astronomy is a humbling and character-building experience. And remember, so Carl Sagan, we lost Carl Sagan the same year that NASA changed to having astrobiology as a term. And a lot's happened in those years since we lost Carl. I hope he'd be very proud of where we are. And I also think that maybe he would add to that it's not just astronomy, but it's astrobiology. It's all of us trying to answer this question of whether or not we're alone. That really is this humbling and character-building experience that lets us now kind of start looking beyond ourselves. And so I think I'll wrap it up there. I have other slides, and I'd love to take any questions anyone has. I have no idea how long I've been talking for, but I'm more than happy to chat with anyone if you have questions about life. I could also just keep going on about cool things in astrobiology as well. So,
well, man, that's a great. I mean, every slide you did there, I was like, yes, but I just had my mic muted so I wouldn't interrupt you, because that's, you're talking our language when you're talking this kind of stuff. And I'm so happy you brought up the Drake equation because, I've tried to. People ask us, when we do these outreach events for middle schools, for the Beaumont Children's Museum, or wherever we're at, is there aliens? Have y'all ever seen aliens? Of course, we've never seen aliens, but there is this equation that's like, yeah, there's probably, and I don't know, Graham, maybe you can educate me. I've heard 10,000 civilizations that are up to the level of, or maybe close to where we are, but maybe that number has changed over the years. I know it's a kind of a guess anyway, right?
Well, the funny thing about the Drake equation, and it's something that makes people like me cringe, whenever you hear in the news about how there's some new use of the Drake equation and we now have a new number, and it's 33, or it's 10,000, or it's a million, or whatever the number is, the Drake equation in its current form and with our current knowledge isn't supposed to give you a single number. We don't have that much knowledge right now. We're missing out on so much. We don't know how many planets are Earth-like worlds around other stars. We don't know what the fraction of Earth-like planets are. We don't know what the likelihood of life is to occur on an Earth-like planet, let alone maybe life is more common in ocean worlds like Europa and Enceladus and Titan. Maybe most life in our universe is not Earth life and not on rocky terrestrial worlds. Maybe there's a lot of gas giants that have huge biospheres in their atmospheres floating around and doing all kinds of cool things. And so we don't know. We don't know whether or not it's important to look for Earth-like worlds. It's a good place to start, and that's what we're doing. But we just don't know. There's so many possibilities with the Drake equation. And Frank Drake himself, he never intended for this to be, an equation to give you an exact number. It was meant to be a thought experiment. It's a way for us to consider what we know right now and what we don't know. And in the years that have passed since he first formulated this, we actually do have a much better idea on some of those numbers. The very early numbers we have a lot better of an idea of now. We actually have a much better knowledge of how many stars are in our galaxy and a good knowledge of current star formation. We're starting to learn a bit more about some of these things that are going on, but there's still a lot we don't know. How many civilizations develop intelligence and develop communication? And we don't know. Also, with lifetime of a civilization, maybe it's 1,000 years, maybe it's 1,000,000 years. But we also have this issue. Life on Earth is probably around 4 billion years old. We have really good evidence for 3.8 billion. And if you really want like really good evidence, 3.5 billion. But there are debatable pieces of evidence for 4 billion, maybe even more than that. That's been a long, long time that we've had life here. Our genus is only 2.5 million years old. Our species is about 200 to 300,000-ish years old. We haven't been around for very long. And then civilization, depending on what you want to lay down for where you start civilization, we're only looking in like the last 10,000 years. And we've only really been ourselves communicating as a civilization, sending radio waves out into space for a little over a century. And so that makes us question, are other beings the same way? If life forms on other planets, does it take a long time there? Does it take 4 billion years? Do most worlds take 10 billion years? Maybe most worlds can't get intelligent life because their stars burn out before they get there. Or maybe we're really slow. It's possible that we were really, really slow to the game. Maybe most planets get intelligent communicating life after 500 million years or a billion years. Maybe some evolutionary advances happen faster in other worlds. And so there's just so much we don't know about the Drake equation. I do see a comment that I think came in from YouTube from Triskelion.
Yeah, Adam Colville, a good friend of ours. He's a member of the Astronomical Society itself.
Awesome. Well, thank you, Adam. I appreciate this question. What are my thoughts on the Kardashev scale? So for those who are watching, the Kardashev scale is an idea in trying to understand how civilizations might use energy. There's been a lot of other variations on it since, because as I'll explain here in a moment, the scale itself is really considering much bigger civilizations, much more advanced civilizations than our own. The Kardashev scale basically says that we're like a type 0 or 0.5, whatever you want to call it, civilization. A type 1 civilization on this scale is when a civilization can actually harness the energy of their entire biosphere, of their world. And there are different ways to define what that might mean. I think a lot of us think that if we have nuclear fusion, that basically would kind of make us a type 1 civilization. There's a lot of arguments there, a lot of debate of what that could mean. But you start getting these other scales then that take you out into some of these ideas in looking for alien life, that we start looking for things called technosignatures, signs of technological activity. One of those you might have heard of is the Dyson sphere. So Freeman Dyson proposed this idea that maybe instead of looking in just radio waves for communication, maybe we should look in infrared. Because maybe there are beings out there who, as Kardashev placed on the scale, are type 2 civilizations, where they're utilizing all of the energy of their star. And there are different ways that could happen, but one that's been proposed by Freeman Dyson would be to build a large spherical structure, a technological structure around the entire star system. So a massive stellar structure that would then absorb all of the light, all of the emissions from that star. And so we were looking out in space, we wouldn't see that starlight. We wouldn't see that as a star. But as Dyson proposed, that sphere then should be experiencing black body radiation. It should be emitting radiation in the infrared. And so what he argued was that maybe we'll see these little, like these indicators of infrared, these big spheres of infrared in space-time that would suggest to us that there could be a type 2 civilization on the Kardashev scale. And then the Kardashev scale kind of gets a little bit wilder after that of how much energy you might be using. So we don't have to really talk about that, but it's worth looking up if you're into this idea of how advanced might aliens be. It's worth looking into.
Yeah, and so what I'm getting is on the previous thing, the Drake equation. I think your answer was 5, definitively, right? Five civilizations, right?
Yeah. So you play with the Drake equation, you can get 1, which is us.
Yeah.
Or some of us think that maybe there could be millions or more. And so it really depends.
And what's really scary is on the Kardashev scale, what's the bias? Is it more zeros or is it more 2s? Did they burn out before they even get to 2? Like you said, there's a lot of variables in this that and it's the unknown unknowns, right? Those little integers that may come in 100 years when we learn something else about astrobiology or just stellar evolution or whatever it may be. It'll change the game a little bit. Like you said, there's always new information coming in, which makes what we do as astronomers and you as an astrobiologist, I mean, you got to be like so excited to go digging around on Europa, because I am, as an astronomer, just a guy with a telescope in his backyard. I'm like, this is where it is. Or Titan, I took a talk in at Mount Wilson about Titan, and I didn't know about the goop, as we've been talking about, and it blew my mind. And so I'm so glad you brought that up, because that's just really interesting stuff.
Yeah, I should mention, I mentioned Europa Clipper earlier, that it won't be landing, but there is a really wonderful mission plan. It's at the concept stage, so it hasn't been selected, it hasn't been funded. Led by Kevin Hand of NASA JPL. I'm very proud that my PhD advisor Alexis Templeton was one of the co-Is on this proposal for this concept mission for a Europa lander. Which again, it won't be drilling down through all the ice, but the Europa lander, as it's currently planned, would be able to dig down a little bit and get some samples from the near surface. And so maybe in very soon we actually will be digging around on Europa, and that's really, really cool to think about.
Yeah, because no telling, what we're going to see. I mean, like you said, there could be vents. Being that close to Jupiter, you probably still have a molten core because of the tidal pressure from the gravity of, Jupiter tugging and pulling on that core to keep it.
You have to remember that Io, or Io, in the European pronunciation, is the most volcanically active world in our solar system. So there are more volcanoes erupting on the surface of Io, or Io, at any given time than there are here on the Earth. And that's because of that flexing, that heating being caused by Jupiter, as well as the orbital characteristics of Io, Europa, and Ganymede.
Which are great telescopic moons, by the way, guys. Even binoculars, right? If you have the right size binoculars, you can take in the Galilean moons, as it were. And we got Bill Dixon here with us, member of our club. Excellent presentation, Dr. Lau. Thank you. You are blowing our mind. And I agree with that. There's nothing wrong with that. Whole statement is 100% truth.
Well, thank you very much, Bill. I appreciate that.
Yeah. Bill's a really cool guy. We got a great club. We've got a lot of really awesome minds in our club. And again, Howard Miner is one of those minds. Again, I started in the club, I think in 2009, and he was really one of my great mentors. That was, again, don't do that, do this. And I'm like, okay, well, great. I was going to do that, but now I'm going to do this because you said so. And it always made sense. And so if there are any last minute questions for Dr. Graham Lau, obviously throw them down in the chat and we'll get to them as we continue on here. We do have a little bit more. We have a little presentation from Howard Miner as we wrap things up. So again, if y'all do have questions for Dr. Graham over here, he would love to field those questions, and I would love to hear his answer to those questions. So go crazy, don't flat earth us, but let's see if you can stump the doctor. And then what I'll do now is I will share my screen and bring up Mr. Howard Miner's, if I can find give me 1 second, Howard. I think I may have, there we go.
I don't want to take away from Dr. Graham's report he's got going on here. It is absolutely fabulous, and it blows my mind. I know that.
There you go, Howard. I guess I'm gonna put this into big screen, so I won't be able to see the comments or whatever, Howard. So
okay.
If you do, you'll be able to see the questions though if they come through. So okay. I'll go ahead and hit that button there. There you go, Howard.
All righty. Well, I just have a little short thing here. I wanted to talk about how amateurs in the old time astronomy, which I'm going to say maybe starting at the 1950s and going on back to the 1800s and even farther, maybe back to Galileo. But anyway, things were done differently up until really just recently, as technology has taken us. But anyway, I wanted to start off with an observer who did things manually. And basically, as you all probably get the idea, I'm a manual observer. I don't have go-to and all this stuff, and I got usually inexpensive gear. And so, but I've been observing off and on for 60 years. And so, without a further ado, there was a book written about Leslie C. Pelletier, and it was called Starlight Nights. And this book has really become a classic for how the dream of astronomy comes forward and in your life. And he was born in 1900 and died in 1980. But he, as a young boy, which I'm going to say younger than 10, and they lived in the countryside of Ohio, and he gazed at the stars at night as a youngster. And so he formulated wanting to learn more and more and more. And as he became an early teenager, he was able to purchase a 4-inch refracting telescope. And of course, that's about all you had a choice of in those days. And it was all manual scope. And so this book is a must read for people. Unfortunately, I went out on to Amazon to check out the book and how much it was going to cost and that kind of stuff. Well, it's out of print. And then not only that, the prices on it are terrible.
Astronomical.
Off of eBay, you can go anywhere from $75 to $300 to $500 for this book. Now, when I read it, and that's been 15 years ago, I got it from the public library, and I read it from the public library. And I wish I'd bought it at the time, of course. But anyway, beside that point. And anyway, that's where you get your start as a young person. And you get it from somebody dreaming about the sky. And so much that he was saving his chore money till he could buy a telescope himself. And he started out with that. And he, as he worked on through his life, he, in the beginning really too, he got noticing that stars were different brightnesses at different times. So he was recognizing, he not knowing what he was seeing, he was recognizing variable stars. And that kind of became a theme of his life. But he also ended up discovering comets in his later life. I think he even observed a little in Edwin Hubble's later years. He observed with him a little bit. But he was an amateur astronomer. And he ended up and discovered 12 comets, 10 of which still carry his name today. And in a span of over 60 years, he logged more than, that got cut off. He logged more than about 150,000 variables. I think it was 230. That comes back to my mind. 230,000 variable stars he logged in his lifetime. So that's really unbelievable. And so anyway, distress manual telescopes, you need to learn about the sky. Okay? People who came from a time in the early 1900s or 1800s, people lived slower and they studied things. They read about astronomy. And so anyway, it's not like today with the go-to situation and you hear them talking, you know, I logged 15 objects the last hour. I was doing really good. I got 45 for the night. Wow. And, you know, when I was reading back at the Texas Star Party and Okie Tech and this stuff, you know, and I thought I was speeding through the thing. And if I did 4 objects, logged them, did a little short sketch, you know, and put down all the pertinent telescope information. If I did 4 an hour, I thought I was really flying. And, but anyway, starting off, you need to learn your constellations. If you're going to become an amateur astronomer, you've got to know the stars, whether you have a push-to telescope or a go-to telescope. It becomes essential for your whole well-rounded astronomy life. And another thing you need to do is learn the Greek alphabet. You know, we all know alpha, beta, gamma, but then it kind of drops off from there. And so, and not only that, once you learn the alphabet, then you got to know the symbol. Because as you look on Sky Safari or a paper copy atlas, here, what's these little marks on here? What do you call that thing, you know? And so you really need to learn the Greek alphabet. You need to learn the top 20 stars in the sky. That helps you. Out of the top 20 stars in the sky, almost any direction you face, you're going to see one of them. Not all of them, but just one is all it takes to know that orients you to your observation of knowing what part of the sky you're in. And of course, then you're able to say, oh, well, the constellations of such are here, and so on. And then another thing is starting to identify asterisms. Asterisms is very important to know what an asterism is versus a constellation. Of course, the first thing everybody thinks of is the Big Dipper as a constellation. No. And it's an asterism. And it's Ursa Major is the constellation. So, and then the next thing for a manual observer is learning how to star hop. After you've learned these other things, now you're getting down to where I can look at the sky. And so you need to be able to star hop to get to a star. And hopefully you can start star hopping at one of these 20 brightest stars in the sky will get you started. If not, something that you know about yourself that you can start closer to the object. But anyway, I wanted everybody to know about Pelletier and that there was lots of other books written about him. And get on Amazon and you can find other books that aren't such a collectible. And maybe someday you'll be able to get the book Starlight Nights. And if you can, I would pay the extra money to get the thing for sure.
If you see it at a garage sale, what he's saying is pick it up.
Yeah. Somebody doesn't know what it is, you pick it up. That's for darn sure. And so anyway, I brought a chart here now. Go to that on telescopes.
Oh, there we go. Oh, let's see. There we go.
Yeah, that one. And I don't know if everybody can read that or not. It's kind of small. But anyway, I've gone back and I looked up a few telescopes back to 1876 that were available for purchase. And the top one there is one from 1876, a Browning 6.5 inch. And of course, it's a refractor. And it's an equatorial with setting circles. And everybody has digital setting circles, but weren't old setting circles wonderful? No, they weren't wonderful. They were not very accurate. And depending on how big your telescope was, the bigger the telescope got, it got harder to use the setting circles. But anyway, so much for that. But anyway, here are the first Browning telescope, sold for 88 pounds. And they're saying it was $450 US dollars. And the dollars that are out here on the far right are $2,001. So, you know, it's probably a third higher today than what it is there in 2001. But then that little telescope would have had a value of $7,400, which, you know, you look at that today, and if that's a quality instrument, that may not be so far out of line. And then there's another one there, $6,500. It's another 6.5 inch import. And it had no driving clock, but it did have setting circles. And of course, all these telescopes are equatorial. And nobody knew what a Dob was. And so anyway, it goes on down the line. And 1906, Brashear had a 6-inch equatorial with setting circles and a drive clock, and $650 then for it, $12,700 now, or in 2001. And so, so on like that. And then came along in the 50s, came along a company called Edmund Scientific. And a lot of people jumped on their little scopes, and pretty reasonable in price. And I got a 1952 Skyscope listed there. And that Skyscope was my first telescope. And my brother was stationed in the Korean War in California, and he came home on leave one time. I don't remember exactly when, August maybe, and in 1952, and he brought me this Skyscope, and it was $29.75 or $29.95, something like that. And it was a fine little 3.5 inch reflector, but it had a equatorial mount, and it had got a picture of it here on the next page, which we'll get to in just a second. But I just wanted to mention in 1960, Cave Optical Company came along and started more or less, not really mass producing, but they were making telescopes pretty fast. And they had decent quality scopes also. And then there's a Criterion, 1960 Criterion 6-inch telescope. I want to tell you, I dreamed if I could ever had a 6-inch RV6 Dynoscope. And of course, that never happened. I kind of passed that up anyway. But anyway, they were about $200. So let's go ahead to the next deal. Well, yeah, there's David Levy. Well, about 10 years ago, in an April issue of Sky and Telescope, I turned the page, and there he was with an article, and it was showing him with this picture with this Skyscope. And that was my first telescope. And so anyway, it was a 3.5 inch mirror, 35 inch focal length. It had Ramsden eyepieces, which is just 2 lenses with an airspace or a spacer between them. And you just took them out, and you wanted to clean them and put them in your mouth, rolled them around, stuck them back in the deal, and they were ready to go. And it really had decent decent pictures of Jupiter and stuff. You know, I learned the Galilean moons and learned belts on Jupiter, the bright bands, and so on. And so, anyway, that was my first scope. And then let's move on. And David Levy, then I ran into David at the Texas Star Party. He had a presentation there, and so I went up after the presentation and was visiting with him about the telescope. And after a few minutes, he said to me, "Now, do you still have that scope?" And I said, "No, I sold it." And he said, "Shame on you, shame on you." And so I got admonished by David Levy, and so I said, "Bye." Anyway, that was so much for that. And then this picture Will's got up there now is my 10-inch homemade equatorial telescope that my dad helped me with. And it's kind of unique. I rolled the tube with, I didn't do it. It's a galvanized metal tube. My dad knew how to get that done at a machine shop and had a tube rolled for the diameter that I needed for a 10-inch mirror. And I went to Cave Optical Company and bought a 10-inch mirror and a secondary. And then I had to go get a spider. I don't remember what company I got that one. It might have been signed to, what is it?
Edmund Scientific.
And then I bought a elbow Army military telescope for a finder. And it was like about 8 power with crosshairs in the thing. And so that's really about all we bought. And everything else we made. Had a cradle for the telescope, was all made out of wood. We went, Dad took me down to the pipe shop and we bought metal, fittings and a 45 elbow. And then we got the axis rods for the polar axis and so on, that they were about 1 inch in diameter. And we just ran those down through the other pipe fittings and then kind of wrapped thin metal around those rods so that it kind of fit tight in there. It wasn't even machined properly or nothing. And so then had to make a counterbalance and used an old gallon can, and we filled it full of concrete, and that became my counterbalance. And the the post is an 8x8, just an 8x8 construction post. And of course, where we lived was about the 38th latitude. And so the elbow was a 45 degree. So we just cut the top of the post off at an angle so that when the pipe was set on there, that it was at the 38 degree angle. And then just had 2x4s down there for the base that you can see. But I don't know, in between me and my dad, I was 16 at the time, had a kid down the street who was grinding a 6-inch mirror, and I saw that that wasn't going well, so I bought my optic. But anyway, so much for that deal. And we can move on to the next page. And this is my present configuration. I went and bought from Coulter Optics, Odyssey 2 telescope, 17.5 inch, and I bought that in 1963. So I'd had my old telescope that I made from about 56 to 63, and I was ready to move up. And they had a sale on these things. They were like $100 off. They were like $1,200 or in that range, and I think I got the thing for $1,100. And so that's a 17.5 inch. It had almost a 2,000 millimeter focal length, and I used that for from 63 up to 2003 approximately. And then I ran into this guy, McCowan. What was his first name? I don't know. Anyway, he's familiar to some people out of Texas Star Party, Tom McCowan. And he said he could fix me up and build me a Dob. And so I did that. And so that's my Dob in the lower picture. And my wife's in the other picture. She has a Meade light bridge. And so anyway, Jane and I ended up observing for about 15 years together. And she has 4 Astronomical League certificates. Of course, the Messier and the Globular Cluster and Lunar. And one more escapes my mind. But anyway, she did a really good job with that. And we had a heck of a lot of time going to, 3 or 4 star parties every year. And I was able to retire in 1999. And so for 20 years here, I've been without work. Isn't that terrible? And so anyway, that's my little talk for tonight. And the things I wanted to bring out in it is the fact that manual ain't all bad. Today's time, though, it's time to move on, Howard. You need a go-to. And, and so, but people did things more methodically, and they logged stuff well, and they studied it before they moved on to the next thing. And I thought that was really important to their earlier amateur astronomers.
Yeah, and that's such a cool way to see it, though, because, as modern day amateur astronomers, we think that this amateur astronomy market was just always there. And in a certain roundabout way, it kind of was. But like Howard points out, it really wasn't until the late 50s, early 60s that these companies started popping up, these mom and pop shops that now we know as Meade or Celestron or Hoover were just kind of popping up out there. And Howard, so you built that 10-inch scope, and I guess you sold it to somebody and sold them that, told them that it was a home built machine.
Yes. Well, we lived in Tulsa, Oklahoma then, and Tulsa University had an astronomy class going, and some kids there came out, and I'd put the telescope up for sale. And because talk about something cumbersome. It was cumbersome, heavy, hard to get around. And so anyway, but it had great optics. It did have good optics. And I can remember back in the late 50s there, and we lived in Springfield, Missouri at that time, and in the city, okay? I had no problem with that 10-inch mirror hitting 14th magnitude stars, pinpoint objects. And unfortunately, I got rid of that telescope too. And then one night out at the George telescope, I went in when we're having astronomy night there to observe through the 16-inch, and there was a guy in there. And he, as I was walking in the line, he said, "Aren't you Howard Miner?" I said, "Yeah." He said, "I'm the guy who bought your telescope back 20 years ago and was going to Tulsa University." And I said, "Wow, that is great. You still
Small
have
world.
it?" "No." He said, "My wife got it. We're divorced, and my wife got it. And I don't know what she did with it."
Oh, man. I hate to think of the fate of that scope at that point.
And that's another thing. Keep your old telescopes. Don't get rid of them.
Just like guitars. Don't
Just like
get rid of them.
Just like the guitars, yeah.
they all mean something. They all have something in them. You know, you can't just be getting rid of them. But
Yeah,
Adam, what is it, Howard?
it's called money.
That's one side of that exact coin that I was talking about. It's exactly right. There's a value there, monetary and, you know, sentimental. But Adam wants to know, when did you start using a planisphere, Howard? Was that right at the beginning? Was it in the 50s, 60s? I mean, what did planispheres even exist then?
Well, there was no such thing that I ever got hold of. I lived in a small town, and I had a book by a person named Alcott called Field Book of the Skies. And it was published, the last publishing on it was about 1955. And I got everything out of that book. I'll have to bring it to you sometime. It is a terrific book today, yet if you're starting out, it is a wonderful book. And it just goes through and it shows you 2 or 3 objects and a few double stars in each constellation. And it's just fun to read. And it gives it a little paragraph about stuff of each constellation. So it's called Field Book of the Skies. Let's see here. I got it right here.
Back in the day, there was no Google, kids. You couldn't just go, what do these alphabetic numbers mean? Or these Greek alphabet. You had to, like Howard, go digging.
Greek alphabet in it. Alcott and Mayhall. I guess that's off. I'll bet you he was the Mayhall objects and the globular clusters and stuff. So I'll bet it was Alcott and Mayhall.
Alcott and Mayhall. Wow.
Yeah.
And Adam says they had planispheres in the 70s. So, yeah, that was much later. I mean, I've always grown up with planispheres. But
I lived in this little town. In this little town of Wentzville, Missouri, outside St. Louis. And it had less than 500 people. So, you know, I didn't have access to stuff. We didn't have Amazon to order stuff off of.
Yeah. Have to wait a few decades for that.
Made that little telescope, I probably never got into astronomy.
Yeah, and so did your brother share that passion for a long while though with you? I mean, obviously he saw, you know,
He went back to the Army. He was just there on leave, and so he had a little bit of interest in it, but
not as much as Mr. Howard Miner here.
Were so good compared to now, you know. All constellations like Cancer and that kind of stuff, they just stood out. You know, there wasn't any problem seeing Cancer up there in between Gemini and what have you, and Leo, and so that was okay. And so times have changed.
Yeah, and see, that's we need that perspective, Howard. We need, you know, people like you telling us how hard it really was. Like you said, the people back then, they took more time with what they had. I guess probably a lot of the time they didn't know that there were 7,000 or more objects that they could see, you know, with these telescopes. And because, I mean, you know, yeah, William Herschel had been around the block. Charles Messier had been around, you know, all those fun guys. But
when he's, you know, but he read. He learned by reading before that first telescope came along. So he was already educated himself to a point that, you know, things were probably coming easy to him as compared to. And so anyway, he was a great amateur astronomer, no doubt about it.
Yeah, and that's, you know, we've had a history of those along the way. And just, you know, we stand on the shoulders of giants like Messier, like Herschel, like Carolyn Herschel, William Herschel, Carolyn Herschel, John Herschel. Just pick a Herschel. We're standing on the shoulders of those guys. And what's cool is as time goes on, people like Dr. Graham Lau are going to be those Messiers and those Herschels of the field, because when we start going out there, you know, Dr. Lau is going to have probably a species or something named after him. For the work he's doing now, you know.
Yeah, we'll see. I named it after someone else for sure, not myself. I do like, Howard, though, you mentioned, this idea of like learning your constellations, learning the brightest stars. I have to say, when I was in school for astrophysics, how much of a bummer it is that a lot of astrophysicists aren't learning those things anymore.
Yeah.
They're not really learning observational astronomy as much as they used to. Some of them might take a class or two, but a lot of them don't know their constellations.
Right.
And so we would do these planetary field geology trips in my graduate school time. And I'd go out and it'd be, a bunch of us geologists, some chemists, some astronomers all together. And it was those of us who weren't in astrophysics PhD programs who were leading the star tours and showing everyone the constellations and things at night when we're camped out in the desert, because the astronomers were focused on other things.
Mm-hmm.
I have a friend out here in Wood Forest. I live out north of Houston, out by the Woodlands. But anyway, have a friend out here, and he's probably around 60. And so he has become, knowing nothing about astronomy. He started in about 3 or 4 years ago, and he bought him a 10-inch Celestron, and he started doing astrophotography with it. He has become really good quality pinpoint star objects, and he reads and he studies, and he's become a full-fledged astronomy astrophotographer. And so before the pandemic hit, I asked him, I said, well, I've been looking at this object over in Ophiuchus or something, and I was saying to him, he said, I don't know where that is. And he said, I don't know any stars. I don't know constellations.
He just types it in.
Yeah.
And he takes his picture and he posts on Facebook the next day, and everybody writes him little notes. Oh, fantastic job. It looks great. I really enjoyed this picture. And he's probably learning them as it goes on, but
Hopefully.
he didn't need them to start out and be a good astrophotographer.
Yeah, don't tell the young astrophotographers that, because I always tell them you need to learn the sky, even though it's probably more true, like what you just said. But it does help if you know the top 20 star names, like Howard said, because if you're going to get a Celestron, a Meade, or whatever, with a computerized go-to mount, that mount's going to want to know where it is on the planet Earth and what time it is, but it's also going to want to know where a few stars in the sky are. And then you're going to have to, tell them where those stars are. If you don't know where Betelgeuse is.
Star arrangements or something.
Yeah, there's a book. I'm trying to look it up right now that I have on my bookshelf. And I just moved recently, and so I'm not quite sure where this book is at. It's called The Brightest Stars. And I think it's the top 25 brightest stars. But it tells you the star, and then it gives you all of our known history, including a bunch of the science, as well as a lot of the mythology. For all the brightest stars, there's many peoples around the world through time have developed stories that place themselves in the heavens, and the brightest stars are the ones that have the richest star lore around them. So it's definitely worth looking at.
Yeah, like Zubin-el Shamali is my favorite. I mean, it took me 6 years to figure out how to pronounce that, and I'm still saying it wrong. So, because I'm pretty sure it's Zubin-el something else, not Shamali. But then there's Zubin-el Shillelagh, which I know I'm definitely saying wrong, because I think Shillelagh is like an instrument or something. But it doesn't matter how you pronounce them. It matters if you know where they are, because it could be Betelgeuse, it could be Betelgeuse, it could be something else. We don't even know. Because like Graham said, there's history of these stars. A lot of it's Arabic, some of it's Roman or Greek or whatever it is. It's just this old history stuff that those names have kind of just been passed along as we go down the years. And some of that star lore is fascinating. We had Don Davies from the Austin Astronomical Society do a constellation lore talk one time for us, and that was fantastic. Cool. Because like you said, Graham, every different culture calls that star something different, or that constellation, that association of stars is a little bit different. and they all have some cultural meaning, to their part of the world and their culture.
Yeah, the official IAU 88 constellations are mostly set with the Greek constellations. We added some in after that, mostly in the southern hemisphere. But there's a lot of other star lore and a lot of other constellations worth looking into, from Chinese people, the Navajo constellations. I really love the Navajo stories.
Yes.
And some people's also, they weren't just connecting dots in the stars and seeing shapes in the heavens. They were looking at things like the Milky Way and seeing the dark dust bands in the Milky Way. And so you have Aboriginal peoples from Australia who created stories of like the great emu in the Milky Way. And then the Polynesian peoples, that they saw things like sharks and stuff in the skies. And so there's all this beautiful tapestry of stories that come from human interactions with the cosmos.
Yeah, and I wish we could go back retroactively and maybe add some of that lore where it should belong. Like, for instance, what is it? Canes Venusite, Venatici. I don't even know how to say it right because it's just a dumb constellation. It's literally 2 stars, and it's supposed to be some dogs. And it's like, okay, I know the constellation well because there's like a carbon star over there. There's, I think, a pretty famous Messier in, or maybe I'm thinking of Cor Caroli, but Canes Venusite and Cor Caroli. I mean, just pick one of those lame constellations. But then there's the great ones like Orion, and I think it was Anubis to the Egyptians, and a canoe type of thing to some of the Aboriginal Australians, I think, or something like that. And then it was 3 brothers and all this stuff to different cultures. And it's just absolutely fascinating. And then we, as modern amateur astronomers or humans, whatever, we land somewhere in the midst of all that. And we're like, oh, that's Orion, and it'll probably stay Orion for the next 1,000 years if humanity continues, if that one Drake equation number doesn't come up for us, and then we end up in the Great Filter or something like that. But we'll probably keep calling Orion, and Ursa Major. Although, who knows how time will change things. But that's the way it goes. As we're closing out here, guys, I mean, if y'all have any last minute questions for Dr. Graham Lau, now's the time to get those questions in. Or what you could also do is go on to Twitter, Instagram, and all the places and find @Cosmobiologist and give him a follow. You definitely got to do that. I mean, it's mandatory now that it's been said. And Graham, you're posting stuff over there, like your adventures and stuff, because you're a busy guy. And do you have anything coming up, like any excursion? I know it's been really kind of.
Yeah, this pandemic, most of my trips last year were canceled. Most of my trips this year are canceled. The University Rover Challenge, we haven't made a call yet. Usually it happens at the end of May. But this requires, groups of students from around the world to travel to Utah together into the desert, and that might not be very safe. And so we haven't made a call yet there, but I have a feeling the director will make a call on that very soon. I am looking forward, if vaccination programs work. I'm working with a group from the Amity Center for Excellence in Astrobiology in Mumbai, in India, on developing a Mars analog base in India, in the Ladakh region. And I'm really hoping to get a chance to go there with them for a few weeks, sometime in like September or August. To my knowledge right now, all of our trips with New York Times and National Geographic, I haven't heard anything yet for the summer for leading school trips of middle school and high school students on those trips, unfortunately. The pandemic's just been very hard. But I am giving a talk next month for Fisk Planetarium. That's the very large planetarium for University of Colorado here down in Boulder. It's the largest planetarium between Chicago and LA, for those who don't know. And recently, a few years back, got a $17 million update to its system. So it's a beautiful dome, beautiful planetarium. The star projector in there is incredible. Now, the talk I'll be giving will be online on their YouTube channel, but it'll be a talk called The Craziest Creatures on Earth. And it's about weird biology on our planet. And not just things like extremophiles, like tardigrades and other weird microorganisms, but also things like hummingbirds and greater wax moths and whales and the murmuration of starlings and some of these kinds of things. So that should be a very fun talk.
That's awesome, man. Definitely keep me updated on that if you can, and I'll definitely share a link here on Deep Sky Dude so that y'all can go watch that particular talk, because I don't want to miss that. while we're doing this, though, there was some questions that came up earlier that I just didn't want to, I missed a lot of y'all's comments tonight. I apologize. When there's a special guest, I don't want to just flood their talk with too many comments, but I like to definitely throw up ones when I can. And this one, I'm assuming goes to you, Dr. Lau, because it came in during your talk. And Carl's Cosmos wants to know, what are you excited about with this? I know you're very excited about James Webb. We are too. We have like a monthly update that is just like, well, they're still building it and we're still testing it, and they broke it. Okay, but what are you feeling is going to be the nice cherry on top of this little telescope as soon as it launches?
I mean, the cynic inside of me wants to say the launch. just getting this thing to finally launch. We've been waiting for so long for this incredible instrument, and I was very lucky to see the telescope at Goddard Space Flight Center back in 2016. I competed in a science communication competition called FameLab at the Carnegie Institute, and afterwards, my friend Daniel Angerhausen, who is now working on the LIFE mission, which is another next-generation telescope, but then he was working at Goddard. He took my family and I for kind of a tour around Goddard, and we had a chance to see the telescope, which was really cool to be that close to it. I've been so excited for James Webb for so long. I mentioned, that James Webb, one thing it will do is allow us to really look at exoplanet atmospheres, to look at the chemistry of them. And so I'm excited for James Webb from an astrobiology standpoint for that. But also James Webb will just have this kind of resolution that will let us look deeper into time in our universe and further into our universe than we ever have before. And I can say the same thing of actually many of these next generation telescopes. The future, the next few decades, 3, 4, 5 decades of telescopes for space telescopes is going to be incredible. We're going to start uncovering things that we had no idea existed. You mentioned earlier, that there's unknown unknowns. There's things that we know. There's some things we know that we're not sure about. And then there's some things that we just cannot know are going on out there. Some things like gravitational lensing. I mean, we predicted gravitational lensing, but we really required this next step in astronomy to actually discover gravitational lensing was actually occurring in the way we thought it was, for seeing things like galaxies from so very far away. And even things like, our new observatories for looking at gravitational waves. I mean, we predicted gravitational waves. Einstein had first predicted gravitational waves, but we're now able to listen to the mergers of neutron stars and things like that. It's so cool. And for people like me who are interested in cosmochemistry, it's teaching us more about nucleosynthesis. It turns out we aren't all star stuff. We're also Big Bang stuff, and we've known that for quite some time. And we're also atomic bomb stuff and cosmic ray stuff interacting in our atmosphere. But it turns out we're also neutron stars banging into each other's stuff. And we know that now because of gravitational wave observatories. And so with James Webb Space Telescope, with these other telescopes, with all the new instruments we're developing around the world, new particle accelerators, new gravitational wave detectors, new neutrino detectors, there's so much that we're still learning all the time. And honestly, there's probably some young person right now who maybe tunes into the meetings, maybe you've interacted online, who at some point in the near future is going to have an idea, but wait a minute, could this be possible? And they're going to use those next generation telescopes and these new instruments, and they're going to teach us something new about the universe that we never knew before. And that's really cool.
Yeah.
Absolutely. Yeah. And Robbie's, question here is essentially 1,000% true. Yeah. All telescopes are time machines. If you're a Doctor Who fan, they're kind of like TARDISes, I guess, or is whatever that. I don't really watch that show. I don't want to expose my non-nerdness, but I've heard that discussion. But yeah, they are absolutely time machines. Your eyeballs are really time machines. If you've seen the Andromeda Galaxy with your naked eye, you've seen 2.5 million years into the past in that particular direction, right? The moon is a light second and a half away, so technically it's a second and a half into the past. Not a whole long way.
And technically, looking at your computer screen right now, there's a very brief moment of time it takes for light leaving my face to go to my camera. That's being digitally processed, transitioned through the internet, and then it's coming back out of your screen, and they're still taking some time for that light to come to you. So technically, you are looking at me in a very, very, very near past. And that's the way our eyes work. It's how our ears work too. When you're hearing sounds that left another source and moved through space. They caused waves in the medium of the air around you that then hit your ears, and then your brain processed that. And so very much so, like our telescopes, our microscopes, all these instruments I'm talking about, these are ways for us to enhance our senses. Be it sight, be it hearing, however you want to understand it. I mean, you might think of a gravitational wave observatory more like a hearing than it is actually seeing, because it's listening to waves in space-time. And so we've found these very incredible ways to enhance our senses and to allow us to perceive things that occurred in the past far away that are now arriving at us. And that's just freaking groovy.
Yeah. And what I'm mad about the most is that we don't have, like Futurama, a smelloscope, because we can use microphones to hear better. We can use telescopes and microscopes to see better, but we don't have a smelloscope to help us smell better.
Yeah, we got to work on that.
Which is sad, because I would make a joke about the solar system, but I'm not going to do it because it's too low hanging fruit. And I think y'all can all make the joke in your head. Y'all all know exactly where I was going with it. Everyone wants to smell Neptune. Okay, so a few last minute comments as we're getting out of here. Sarah Silva was in the house. She says, "My brain is happy from this talk. Thank you."
Aww.
I agree with that 1,000%. I knew Graham was going to knock it out of the park, just coming in here and talking with us for a few minutes. And like he said, this is a conversation. We all jump in here, and even though we're all stuck at home with COVID, being out there, and we're trying to stay away from it, we're still face to face. We're still here doing the thing, which is amazing. There was also some comments here, Graham, about your beard from Sarah Treadwell, which I know you know.
And Sarah is incredible. She was a member, a research associate with me in the Young Scientist program from our research institution. Every year we bring in a fairly large number of undergraduates and recent graduates from around the world to work on projects with our scientists. I'll have 2 of those projects this summer, one working with me with a group from NASA working on life detection and biosignatures, another one focused on communicating and sharing science and astronomy. And Sarah joined me last summer for that group, and now she's a visiting scholar at our organization working with me as well. She's also an ambassador for JPL. She's also going to be working for her local museum, the Burpee Museum, and doing some awesome stuff. And so she's incredible. She does so many amazing things.
And she has a TikTok.
She's also an astronomer, amateur astronomer, and she runs a club. So.
Oh, she does. Wow, look at that. Presidents, I guess, flock together. But Sarah does also have a TikTok. I don't have it on me. I could look it up, but that would, break the cycle here. But we'll get her on one night. Hopefully, we'll have her come on and just hang out with us. But she has a TikTok where she goes through paleontology stuff. And I just found her today or whatever. So I was like, oh, I got to check all this paleontology because I love dinosaurs. I mean, I know you do too, Graham, and I know Howard does too. I mean, no kid growing up at any point has ever said dinosaurs are boring. It's pretty well, maybe some kids have. I don't want to, paint too broad a brush there, but we appreciate all y'all watching, guys. As always, we're just an astronomy club here in Beaumont, Texas, that due to the pandemic, we had to broadcast live, but look at the kind of unity that is brought to us. We may be socially distancing, but we're not really socially distancing. We're physically distancing. We're socially together, I think, more than ever. And I think there's actually a term that's going around, people are tired of live streaming because there's so many live streams out there nowadays. So the fact that y'all chose to fly with the Astronomical Society of Southeast Texas for your flight tonight, we appreciate that. We know there's a lot of carriers out there.
Yeah.
And we appreciate y'all flying with us. And Howard, thank you again for your presentation. Of course, it's always great to hear about where we came from, and so we always appreciate hearing from you. And it's just good to see you, Howard. I haven't seen you in so long. It's just great to have you here with us.
Good. Well, I certainly want to say to Dr. Lau that maybe he can come back and visit with us a year or so down the road, and we can learn what he's been doing over this period of time, and see how famous he's become.
Thank you.
That's awesome. I was going to say the same thing. I was actually going to rope him in and be like, well, yeah, you're going to come back next time and let us know everything's going right. I mean, so
Sounds great to me.
yeah, and Graham is such a great guy. You need to follow him online. He's always got good stuff. I'm always pleased to see his stuff. And thank you, Robbie. We do fly this Friendly Skies here at Deep Sky Dude, or wherever we're at. We're on multiple platforms tonight. So, but Graham, Dr. Graham Lau, man, thank you so much for taking time out of your afternoon, night. I know you're just an hour behind us there, but we really appreciate you, man. You're someone I look up to, and I'm super honored that you said you'd come on tonight and hang out with us and just nerd out, man. So thank you again for that.
Yeah, thanks a lot. I really appreciate being on and seeing all the comments and questions and just being with your group tonight. It's been great.
Okay.
Yeah, and we are the Astronomical Society of Southeast Texas. We are a nonprofit here in Beaumont, Texas. That's where our astronomy club is based. We're mainly an outreach club these days. I've kind of driven the club into mostly outreach, which is okay. And that's what we do. We do online outreach star parties as well as in person when COVID's not around. You can be a member of our club if you do want to. $30 for your whole family. And you're actually part of the Astronomical League when you join our club. So it's like you join our club and you join the Astronomical League all in one go. So that's definitely an option. You guys can do that if you want to. Contact me or go to our website, asset-astronomer.org, or go to the Facebook and send us a message. We'd love to let y'all know how to join our club. Or if you just want to watch the meetings every month, have at it. We would love to have you there as well. We will go back to in-person meetings eventually once everything is good and we all have shots in our arms pretty much. And when we do that, we're talking about maybe continuing the online broadcast of it. Even though we're in person, it may give us the opportunity to pipe people into the online or to the in-person things, or pipe presentations out. We'll have stuff going in and out if we can do it that way. So we'll definitely cross that bridge as COVID goes away. We'll cross that bridge as we come to it. And hopefully, for the sake of Graham and all his projects and Howard and the star parties that we all love, hopefully sooner than later we can get back to that and go back to our star parties and have in-person talks and sit next to each other at chow, and hang out and share ideas, because that's what this is all about. And that's, as an astronomy community, I think we do a pretty good job of sharing information and having a good time doing it. At least I do. Tonight was a blast. I can't say enough good things about it. And I can't wait to go back and watch it again, because I know there's some stuff I missed. But y'all in the chat room, thank y'all for hanging out with us. Sharon Rigsby, the woman who runs our planetarium for us down here in Beaumont, Texas. We can't wait to get back with you again, Sharon. Thank you for hanging out with us as always. Such a great educator, Sharon is.
Person.
Yeah, very VIP, absolutely. MVP, VIP, whatever 3-letter designation you want to put on Sharon. She is very, very, very awesome. So until next month, guys, we will be back on the second Friday of March. I'm not exactly sure what that date is, but you guys will see the notifications come out either here on Deep Sky Dude or the Facebook for the Astronomical Society of Southeast Texas. And if you're a member of the club, you'll get emails going out about when we're going to be live. And we appreciate y'all hanging out with us. And again, Dr. Graham Lau, such a great thing you did for us tonight, man. You expanded our minds, and we really appreciate that.
Yeah.
Thanks.
Thank you.
And all right, so until next time, guys, take care of yourselves. Take care of somebody else. I can do that too. I couldn't for a long time, but there we go.
Yeah. I had to work on the fingers.
Yeah, it was when I was a kid. It was like, what's going on here? I don't get it. Have a great night from South Texas, John. What is it, Howard?
I got arthritis in the fingers.
That's not funny, but I mean, I guess it's coming for all of us. So I guess we can live long and prosper while we still can, right? Thank you guys again. Y'all come see us next month, and we'll be here for another meeting, and I'll be doing that Boca Chica thing. So if you're interested in going and watching launches down in South Padre Island, Texas, because there's launches happening down there now, come back and I'll show y'all how to do that. Until then, guys, again, take care of yourselves, take care of somebody else, wash your hands, wear your mask, get your shots. Let's get through this and get back to annoying each other in person, which I can't wait for. So, guys, y'all have a great evening. We'll see y'all next time.